All right, so we're going to get started with the second half of chapter 5, and we're still going to work a little bit with these rational expressions, but what we're going to do for this first section, for section 5, is actually solve them. So we're going to solve for the variable. So when they have like an x or whatever letter they're using within the rational expression, we're going to be able to solve and say like what we think x should be equal to. Remember, a rational expression is an equation that contains one or more fractions. Okay, so rational means that you have like a fraction. So for example, x over 2 plus 8 over x equals 1 over x would be an example of a rational expression. Notice how you have an x, and so what we would want to do is figure out like what does x equal in order for all of this to balance on either side of the equal sign. So when I plug in x's and I have those as fractions on the left side and I add them, it's the same thing as when I put 1 over whatever x should equal there. In order for us to solve rational expressions, we want to find the least common denominator. So similar to what you guys were doing when you were adding and subtracting fractions, is figure out what is that denominator that you need both of the fractions to have, and then eliminate all of the denominators by multiplying each individual term by that LCD. The reason why we're doing it this way, instead of just multiplying the fractions by like what's missing, is because I'm trying to get rid of the fractions altogether, because it makes it a lot easier for us when we have to solve it this way. So let me show you an example here. We're going to start with a really basic one. So I have 2/3 plus 5 over 6 equals 1 over x. So I want you to look at your denominator pieces, 3, 6, and x. And I want us to first just state what the least common denominator would be. Good, 6x. So the biggest, or like the smallest number that they can all go into is a 6. So I want all of them to have a 6. And then I also need that x that's on the end there. So my LCD is going to be 6x. Now what I'm going to do from here is I'm going to multiply each fraction. So there's 3 of them in this problem. So I'm going to multiply each one by 6x. So I'm going to take 2/3 times 6x. Then I'm going to take 5/6 times 6x, and then that 1 over x times 6x. So this is a little bit different than what we were doing when we were adding and subtracting, because when we added and subtracted, we would have only multiplied the fractions by like what they were missing to get to the least common denominator. In this case, I'm multiplying all of them by 6x because my goal is to get rid of these fractions. So what I'm going to do here is, like, I can see 3 can go into 6 twice. So I'm going to reduce this 3 to a 1 and change this to a 2. So now I have 2 on the top times 2x. Okay, which is going to end up being 4x when I simplify that. For the second fraction, what can I reduce? Good, the 6's. So both of these are going to become a 1. So I have left on the fraction is just that 5 on the top, and then times x, or that's going to just say 5x. And for the last one, what can I reduce? Just the x. There's an x on the bottom, there's an x on the top. So I'm left with 1 times 6, which is just 6. So doing that prevents me from having to deal with fractions here. I got rid of all of them by doing some elimination. And so then what I can do is add my like terms together. So I have a 4x and I have a 5x. So 4 plus 5 is 9. So I have 9x equals 6. The last thing I'm going to do is divide by 9. And I'm going to reduce. 6 over 9, I could take a 3 out of both of those. So x is going to be the same as 2/3. Now, if I wanted to check this, I could take 2/3 and plug that into my equation, put it in for that x. I could add 2/3 and 5/6, and that should be the same thing if I took 1 divided by 2/3. Okay, and you could easily just use your calculator to type that out and do a quick check. But that is what should happen when we do that. Okay, let's take a look at the second one here. For this one, we have x minus 3 over x plus 2 equals 1 over 5. So my denominators are an x plus 2 and a 5. What would be the least common denominator then for this problem? Good. So what I'm going to do is just leave it 5 times x plus 2. Because it's going to make my simplifying a little bit easier if I keep them separated. Okay, so just like what we did on the last one, I'm going to take each fraction times the 5 times the x plus 2. So I have x minus 3 over an x plus 2 times 5 and x plus 2. And then that's going to equal that 1/5. And we multiply that by the same thing, 5 times x plus 2. So what cancels off on the first set? Good, the x plus 2's. I have 1 in the denominator. When I multiply times that 5x plus 2, that's in the numerator. Okay, so if it helps you, think of this as being like over a 1. Over a 1. That way, if you need to see those separate fractions so you can see why I'm crossing off the pieces that I am, it's because you've got those fractions like you had when you were multiplying fractions at the start of chapter 5. And so anytime that you see something in the numerator and in the denominator that match, you can cancel them off. So I'm going to go ahead and cross off these x plus 2's. So that leaves me with x minus 3 and a 5. What can I cross off on the second set? Good, 5. So this 5 and this 5 are gone. So I have, yeah, the 1's could cancel basically off 2. So I'm left with x plus 2 over here. Now I have no more fractions, so it's just solving this using your guys' like basic algebra skills. On the left side here, let's go ahead and distribute that 5. So it's going to say 5x minus 15 equals x plus 2. What would you guys do next? So let's subtract x. So that says 4x minus 15 equals 2. Next thing would be to add 15. So I have 4x equals 17. Okay, so then I would divide both sides by 4, and it's okay if you get fractions. Just like we saw in that first one, we got a fraction. So x is going to equal 17 over 4. And I'm going to go ahead and just leave it there. I can't reduce that at all. I'm not going to worry about writing it as a mixed number. You guys can leave it improper. Okay, now there's going to be some cases when we solve these that you may have like an x squared show up. And so then when you go to solve it, you have to factor, and then you have 2 numbers for x. So you have 2 solutions. When that happens though, you need to make sure that you check your solutions. So if you go back and you plug it in, you want to make sure that it does give you a true statement, because if it doesn't give us a true statement, we have to get rid of it. And those are called extraneous solutions. And basically what that means is that it's a solution that doesn't work. It doesn't hold the equation to be true. So if I plug in that value of x, I don't get the same thing on either side of my equal sign. And so they're not actually equal to each other. When that happens, you want to go ahead and just throw that solution out. Another situation that you want to look out for is if a value gets excluded because it causes your denominator to equal 0. So back when you guys were first starting with multiplying and dividing and adding and subtracting those rational expressions, you had to state like which values x couldn't equal because it caused you to get a 0 in the denominator. You want to make sure that you still watch out for those kind of situations. All right, so let's take a look at an example here, and then we'll also make sure that we check for any solutions that just don't work for our problem. All right, so I have 1 over x minus 1 equals x over x minus 1 plus x over 6. Can you guys tell me what the least common denominator would be? Good, 6, and then times x minus 1. Okay, so that's what we're going to multiply all three fractions by. So I'm going to get that set up first. All right, in the first fraction, I can cancel off my x minus 1s. I can do the same thing in the second fraction because they each have an x minus 1 in the top and in the bottom. So I'm just crossing off those pieces. In the last fraction, I can cross off the 6s. Okay, so from the first fraction, what's left is a 1 times 6. 1 times 6 would just be 6. Then I have my equal sign. What's left in that second fraction? Good, 6 and an x. So we're going to write that as 6x. And then plus, now on this last fraction, I have x and I have x minus 1. So I need to make sure that I distribute x times x and x times that minus 1. We're going to have an x squared show up for this problem because x times that x is going to be x squared. And then x times a negative 1 is negative 1x or just negative x. It changes its sign. So what I'm going to do now is get everything on the same side of the equal sign. And I like to try to keep x squared positive if I can. So I'm not, in this case it's already positive, so I'm not going to move my x squared at all. What I'm going to end up doing is combining the 6x and that minus x. And then I'm going to move the plain 6 from the left side over to the other side. So I'm going to keep x squared as is. 6x minus an x would leave me with 5x. And then for this 6 that's left over here on the left side, I'm going to subtract it over, so it's just going to change its sign to a negative 6. And so now you can think of this as like being equal to 0. Like I said, because we have x squared, we're going to want to try to factor this. So can you guys think of two numbers that multiply to a negative 6, add to a negative 5? Okay, so positive 6, negative 1. Then I set those equal to 0. What are my two answers going to possibly be here for this problem? All right, now looking at those numbers, negative 6 and 1, we have to see if there's any extraneous solutions. First, I would do the check of, do either of these cause my denominator to equal 0? So going back up to the original problem up here, if I plug in either of those x's, negative 6 or 1, into the bottom, is a denominator going to equal 0 in any of them? Well, that one, the 6 doesn't have an x with it, right? Because I can take negative 6 divided by 6 and get a negative 1. So I think negative 6 is okay. What's the issue if I use 1? what does your denominator say on those first two fractions? So if I put in a 1 for x, what's going to happen? The denominator is going to be 0. Can I divide by 0? No. So you need to throw out 1. Just cross it off. It's not a good solution. Because if I plug it in to one of those first two fractions, it's going to cause me to have an undefined answer. I can't actually evaluate it. All right, why don't you guys try to do number 2? So for number 2 here, what would be the least common denominator? Number 2. Good, 10x. So the number that 5 and 2 can both go into would be a 10. And then you need an x. So we're going to multiply all 3 fractions by a 10x. Okay, and then I would go ahead and do some reducing here. So like 5 can go into 10 2 times. So you have 2 times a 2x. For the second one, you can get rid of the x's. So you have 1 times 10 left. And for the third fraction, after the equal sign, you can make the 2 go into 10 5 times. So it's going to end up having a 1 and then 5x left. Okay? Now you don't have to write that out explicitly. Like if you can go ahead and reduce and then multiply, you can do that all in one step. Now I'm going to multiply here. So I have 4x plus 10 equals 5x. What would you guys do from this point? Or what would you do at this point? Subtract 4x from the 5x. So that's going to leave us with just an x over here equals 10. And if you want to write it the other way, you can always just flip it around if you like it that way better. Okay, but it says the same thing, it's just backwards. So x equals 10 for that one. Okay, let's take a look at number 3. So when you're trying to find the least common denominator, I would maybe look and see if you can find like any of the denominators that need to be factored first. So like on this first one, I can take a 2 out. And so it says x minus 2 there. Because that might help you see that the least common denominator is actually that 2 times x minus 2. All right, so I'm going to take all of these fractions times 2 times x minus 2 now. So on the first one, even though it says 2 times 2x, or sorry, 2 times x minus 2, that is the same thing as 2x minus 4 because I had factored it to get there. So I'm going to go ahead for this first fraction, everything cancels from the top and from the bottom. And what I'm left with is just that x minus 3. What can I cancel off on the second fraction? Okay, so x minus 2 on the bottom and on the top are gone. What am I left with? Good. X times 2 or 2x plus. Now on the last one, because 2 wasn't a fraction, it just says plus 2. I can't cancel anything off because there's no denominator. There's no fraction over here. I mean there is, but it's all over a 1. So I do have to just multiply this. So think of it that we have 2, maybe distribute this. Because then we have 2 times 2x minus 2. You just want to make sure you be careful when you multiply that you're multiplying correctly. Because then you're probably going to want to distribute one more time here. So that it says 4x minus 4. Nope, that's not right. Because this should be 2x minus 4. So then it becomes 4x minus 8. Now we can combine like terms. So I have x minus 3 equals 2x and a 4x is going to give me 6x and then minus 8. What would you guys do next? What would you do next? Okay. So I have negative 3 equals 5x minus 8. Next. Add the 8. What's negative 3 plus 8? Okay, what's my x going to equal here? 1, because I'm going to end up dividing by 5. So x is going to equal 1. All right, we've got one more here on this page. I'll give you a couple minutes. If you want to try it on your own, you can, and then we'll go through it together. I will just give you a starting point here. I would factor this first fraction's denominator by taking out an x, so that it says x minus 1 times that x out front. This is going to be your least common denominator that you want to work with. Okay, so after I have it written out as multiplication problems here, for the first fraction, everything from the denominator simplifies with what we multiplied by. So I'm left with x plus 5. And then minus. On the second one, your x's cancel. So you have to take 3 times x, 3 times negative 1. So that says minus 3x. And then it's negative 3 times -1, so that becomes +3. You got to watch your signs on these problems. For this last one then, the x minus 1's cancel. So we take 1 times x, which is just x. On the left side, x and a -3x is going to be -2x. 5 and 3 is going to be 8. And then we have an x left on the right side. I would add 2x over. So we have 8 equals 3x. Then I would divide by 3. And again, I'm just going to leave this as a fraction. So it's just going to be 8 thirds.